In this video, we will get complete explanation of DevOps tools like Git, Maven, Jenkins, Ansible, Docker, and more. But before we begin, consider subscribing to Simplilearn and hit the bell icon to never miss any updates from us.
So the way in which Git is able to accomplish this is that it is essentially a distributed version control solution. And what that means is that when you have multiple developers, yes, you do have a Git remote hub that you connect and are able to upload and download different branches of the code that you're working on. But essentially, as a developer, when you actually have the code, you actually have all of the code, and you're able to manage it directly from your local PC or your local development machine without having to worry too much about the network or the server actually going down. So some of the key things in which Git is really good at, it is a software management tool. It's designed from the ground up to manage code development. It does track the changes on that code easily and effectively. It makes it easy for you as a developer to track your code. The ability for multiple developers to work together is much easier in comparison to other solutions. And this is really the key success point with Git, is that it allows for non-linear code development. So you can actually have people working on different areas of the code that may be released at different times because of what they're working on. So if we actually break down the architecture of Git, it really falls into four key areas of a working directory, a local staging area, a local repository, and a remote repository. So the process you would go through is you would add files to the staging area from your working directory, and this would be usually the git add command. And then from your staging area, when you're ready to actually then commit those files to a local repository, you would use the git commit command. And then from there, you would actually then push your local repository out to the remote repository for a final commit to the remote repository. And this allows then the rest of the team to pull down your latest final changes. So you can be working on your code locally, and you can be using your local staging area, local repository, and when you're ready to commit your work, you can commit it. And then as soon as it's committed, the rest of the team can then pull down the latest changes that you have worked on. And this allows for a complete and holistic checkout and check-in process. And then sometimes you want to be able to go through and then take the checked out code that you're pulling out and merge it with your local code. And the merge process always ensures that you are working on the latest and best version of the code, and everybody on the team is being consistent with the communication of the actual code that's being delivered. Okay, so what we're going to do is we're going to validate that we have Git running on our computer. We're going to then create a directory, add a file to that directory, make some changes to that file, and then use the commit commands to be able to check in the files and validate changes that have been made. So first thing we do is we're going to see if we have Git installed, and to do that you just use the command git version and git -- version, and they'll actually then give you the version number. And now we're going to create a new folder, so mkdir green, and that'll create a new folder, and we'll move our cursor into the green folder by changing the directory. And we can go back into Windows and we can validate that that directory is actually there. So here we go. Let's have a look. We should see it. There's the green folder. If I double click into that, you'll see there's nothing in the folder right now. So what we have to do is we actually have to add the folder as part of a Git project. And so we're going to use our git init, and they'll actually initialize the folder and make it a Git repository. And so let's go ahead and create a file that'll actually go inside of that new initialized folder. And you'll see that there's a .git folder that's been added. So the new text file we're going to create is going to be called class, and it'll actually be class.txt. The extension is hidden by default. In the text file, we're just going to type in the text, welcome to Simplilearn, and save that. Now let's go ahead and check the status of that file in Git. So let's do git status, and you'll see that it says yes, there's a file there, but it hasn't hasn't been committed to the repository. That's why it's in red. So what we have to do now is commit the file to the repository, and it won't be able to track any changes that we do to that file. So let's go ahead and commit the file. So we do commit add class.txt, and they'll add that to the repository. And there we are, it's added. And the final step is we want to do is commit it. And let's do git. So let's do git commit -m. Put in, this will be our first commit, and this is the description. And so it actually shows us committing the file. It's the only item in the folder. So now we can go over to the file that we just created, and we can make some changes to it. So let's open up the file. So it says, welcome to Simplilearn. Let's put in some text afterwards that says, this is my demo. And we'll save that, close that. And now if we go back to Git, we can do a compare and contrast between the original file that we committed and the new updates that we've just done. And we can check the difference by using git diff. And what you'll see is the red text was the original text, and the green text is now the new text that's been added. And so that shows you how you can actually go and create a new Git repository, go through adding files, committing the files into the repository, and being able to see the different version controls. Let's move on to Maven. So why use Maven? So why use Maven? Well, let's look at some of the things that you would have done in the past if you actually building out the tasks. So let's break down what you would have done before using Maven if you were to create a game of football using Java. You would actually have to go out, and for your actual game, you'd have to collect all of the different components needed within the Java environment to make sure that everything would work correctly. And if you made the slightest mistake, you wouldn't get the right output that you needed. The actual process of building and deploying a project really would take quite a lot of time. After Maven allows you to be able to take templates that are stored locally and be able to use those to be able to improve the efficiency of being able to build out your environment by removing dependencies within the application. It makes it a lot easier for you to be able to focus on just writing the code for your game or your solution rather than having to manage the environment within which that solution would be deployed. Now, the focus within Maven is that it is an automation tool, and it's used for projects that have a short period of time. So as you're starting on your environment for building out solutions, Maven is great to get started with. And then if you need to have longer term projects, then you can look at other alternative tools on the market. So 4 key areas that you want to focus on and why Maven can help you is that it does allow for efficient parallel builds to be run concurrently. It's really easy to use. You can get up and started with Maven very quickly. You do have fast access to new features and new configurations quickly within your environment, and the build process that will allow you to be able to visualize your code happens very quickly. The actual architecture of Maven is that the execution and commands are managed through what's known as a POM file. The POM file itself is a project object model, and it's an XML file that actually has the details for the project and the configuration for the build environment. POM file itself will then fetch dependencies from the local repository and will apply any plugins that you may have also included within your Maven environment. The goal is that your software is built much more controlled manner. So what we're going to do now is we're going to show you how to go through and run your very first project using Maven. The first steps you're going to have to do is make sure that you have the latest JDK installed on your computer. So we're going to go ahead and open up our web browser and get this installed on your computer. So we're going to type in JDK download into our Chrome web browser and go to the Oracle website, which allows us to download the JDK. And because we're running this on Windows, we're going to download the Windows version of the JDK. And once you have that installed, so the next step is to actually then go ahead and download the Maven files. So it's going to take us to the mavenapache.org website, where you can actually go ahead and download the version of Maven that you need for your operating system. We're going to go ahead and download the zip file instead of just an executable file. Now this will give you more control over how you install it onto your Windows PC. After the file has been downloaded, we want to go ahead and extract the entire file, so you have the unzipped folder running on your computer. So one of the things that we're going to have to do is go through and set a number of system variables for the JDK and for the path to your Maven files. And to do that, you want to go into your control panel and select the system security and then system settings, and then go into advanced system settings. This will give you access to the edit system variables setting that you're looking for. So we're going to go down to the path variable, and you'll see already that we have pasted in the link to the JDK right there underneath the variable value. If you've installed the JDK, it's likely that it's already installed this path for you correctly. The good news is it's actually fairly easy to install the path to Maven and to the JDK, because all you have to do is copy the path for where the folder is located on your system and just paste it into the variable value under the edit systems variable file system. And that should now get us all of the files, and we can see that we have our extracted folder already on our desktop there. And the system path is now set to where the Maven folder is located. So we also have to go into system protection and set the system path to your Maven folder. Now we have to go ahead and do a user variable that also links to the path of the Maven files. So what we're doing right now is we're just validating that all the files have been extracted correctly. They have, which is good. We can now go ahead and link to this Maven folder. All right, so now what we're going to do is we're going to move over to command prompt. And this is where we're going to do most of our work from here on out. First command we're going to do is mv. So we're going to go ahead and create a new user variable, and we're going to type in, we're going to call this one m2 dash, and then we'll put in the path to the Apache Maven folder. You should be able to use m2-home for your project, but if it's not, you can always use the variable name Maven-home, and that will do exactly the same as m2. We're going to do both here just so we have a backup. So we're going to open up command prompt and we're going to see if Maven is installed. We do that by writing mvn-version. And here we are, yes. So now we're going to go ahead and create our first Maven project. And the first part of creating the Maven project is actually the directory in which we will store the files that will be used to create for our project. So we're just going to go ahead into the folder and we're going to create a new directory, and we're going to call this one, and we're going to call it Simplilearn. And we can just copy the path for that. So I'm going to write the correct path for us. So we're going to change directory, cd, and copy the file location over. All right, we are now moved ourselves over to the Simplilearn folder, and we'll be able to install the POM file, which is what all the instructions for Maven are stored in, into this area. So to do that, we're actually going to use a template that's already been created by Maven, and this is going to be the MVN archetype template. And so you just do MVN archetype :generate, and this will go ahead and create all the files for us. So there can be quite a few files, and they're all being downloaded from the Maven website. So it can take some time, but as you see, we've gone ahead and all the files have downloaded, and we have everything up and running correctly inside of our environment on command line and command prompt. So we'll have some values that we do have to set. The first one is group ID, and we're going to call this one com.mav. And then the next one is going to be artifact ID, and this is going to be mav-project, hit return. And then version is going to be 1.0-snapshot. We'll just put in the same value for this version, which will be 1.0-snapshot. And the package, we're going to call this one com.mav.demo. And then we'll select yes or Y to create the environment, and it will build the environment for us. And what we have now is we have this screen which shows everything is up and running for us. And we have a successful build. So let's go into the Maven folder and just see. There we have our Simplilearn folder. Let's open it up and see what's in there. So we double click into that directory. Yep, and there we are, starting to see some of our files. So it's the same project names there as mav-project. And then we have our POM file that's in there, which is fantastic. Under the source folder, we'll actually see the demo, and we have our app under the demo app. We have our test file as well. So in the main folder, we have a file that's called the POM file, and that really is the most important file that you need for your project. You'll now go in, you'll be able to set all your settings inside of that POM file. But that's it. That's what we have done here. Is we've gone through all the setup that allows you to make sure you have the right files running on your computer, the right files to download from the Maven website, how to install all of the files, the settings you need to make on your Windows computer, and then all the settings that need to be done in the command line to be able to run the application. And then from here, you can actually start running Maven. Now let's look at Selenium as we start looking at testing. So before Selenium, if you wanted to run testing, and particularly if you wanted to do sequential testing, it would take up a lot of time. You'd have to run one test, then a second test, and then all of the other tests, and the actual time elapsed would be quite significant. With Selenium, you're actually able to do parallel testing. So instead of looking at the amount of time it would take to actually run a test and run the test sequentially, the length of time to actually run your test is based on the length of the longest running test, of which in this example, the longest running test is 2 minutes. Now, one of the things that you'll notice with Selenium is that its focus is on web applications, and it is an open source tool, and it's really good at regression and functional testing of web applications. If you're doing a mobile application or if you're doing an IoT application, there are other tools you can use on the market as well. But if you are new to DevOps and you're setting up your first DevOps environment, Selenium is a great place to start, and web applications are mature and allow you to be able to test out and validate the concept of continuous testing in your environment. So 4 key takeaways for Selenium. It really is fast. I mean, fast execution, it's highly accurate, so you can always validate that what you're doing will work correctly, and feedback can be sent straight back to the developer if their code doesn't pass the test. It allows you to script in multiple languages. Again, this is a great way for you to test. The focus is on web applications, but you can test in multiple languages used for web applications, and most importantly, allows for parallel test execution, which speeds up the whole test process significantly. If actually to break down the architecture of Selenium, what you'll find is the actual libraries that you can use for Selenium run in C#, Java, Python, JavaScript, PHP. These are the common languages used to build out web applications. The actual web driver itself is an API driver, which is fantastic because it makes it easier for you to integrate Selenium with applications through API. And you can run the solution through different web browsers, the most popular being Firefox, Chrome, and Edge. So to focus, the Selenium WebDriver codes are being used to build out the client libraries that make it to allow you to be able to build solutions across multiple web application environments. The WebDriver application interface is used to integrate with the application to make it easy for testing. The WebDriver service provides an immutable stateless environment that makes it very easy for you to be able to use protocols such as JSON to wire up your test environment. The driver manages the communication between the browsers and the wire protocol that's used for JSON within the web browser itself. And then the actual commands are then run through the web browser for you to be able to get your results. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here. I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download, and here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version, and we've gone ahead and done that already. So we have everything running, and now the next step is for us to install all of this great content. Okay, so before we actually get into the setup of Selenium, the first things we want to do is we want to make sure that we have the right version of Java installed. And so I'm just using the command window here, and I'm going to type in Java, and actually what I can see now is I do have Java installed, which is fantastic. Otherwise, you'd have to go and download Java from Oracle's website. The next step is to validate that I have Eclipse installed, and I'm just typing Eclipse, and there we are. I have the Eclipse app installed. You can actually download Eclipse from the Eclipse website. The third step I want to check is to validate that I have a browser driver installed. So I'm using Google's Chrome for my main browser, but you can actually go out and download the Chromium driver, and that's the actual core engine that powers Chrome. Interesting enough, being used in the new Microsoft Edge web browser. So you can actually go and download the latest Chromium driver and install that. And then the final stage is to go to the Selenium website and download the jar files themselves. So just do a Google search on Selenium download. And here we have the seleniumhq.org website, and it takes us straight to the download page. And we want to download the latest version, and we've gone ahead and done that already. So we have everything running, and now the next step is for us to install all of this great content. So we're just going to go ahead and open up the Eclipse environment, and it always takes a moment to launch Eclipse. And we're going to go ahead and create a new project, and we're going to call our project XYZ. I think that should be fine. And this is just a test after all. And we're going to go ahead and create a new class file by right-clicking and select New Class. And we're going to go in here and we're going to give the class file a name of Simplilearn. And I don't see the Finish button being selected, so maybe we need to select some other options here. Oh, I think it could be the package name. Yeah, let me go ahead and change the package name, and I'm going to change that to QWE. Yep, and the Finish button has now been highlighted. I can select that. I can go select that and select Finish. And we now have a test page that's up and running, but what we have to do is to validate that Selenium is actually part of the project. So to do that, we're going to go to the source, to the actual source XYZ file, and right-click on it. And we want to validate that all the files are there correctly. And so we're going to see that we have the libraries are there. Yep, there's Selenium. If it's not there, you can select Add External Files and find the Selenium jar file. Select Open, and that would load that in there, and then you hit Apply and Close, and that would then apply it to your project. And now we can actually start writing the code part. So we're going to put this code in the public static void section. And the first command is going to be a system.setProperty, and we want to make sure that we're configuring the WebDriver for Chromium correctly. So we're going to do WebDriver .chrome driver, and then the argument is actually going to be the full network path to the Chromium driver that you have on your PC. So let's see, we have Chromium here. We want to copy that path, and so paste that in. And then after we've pasted in the path, we have to make sure that we also put a link to the actual file that we want to execute, which in this case is chromedriver.exe. And then we want to make sure that the WebDriver is pointing to the new Chrome driver. And you'll notice that there's a couple of red colors on here, which means that we don't have all of the public classes imported correctly. So you can right click on that and say import the WebDriver and just select that real quick, and that adds the import correctly at the top of the page. And the same for Chrome driver. And that's just a very quick way when you're working in Eclipse to import additional files. So before we actually start our test, we want to make sure that we've actually cleared out any potential browser cookies that would be within the Chromium driver. So for that, we're actually going to go ahead and we're going to write a script that allows us to remove the cookies. So we want to do driver.manage and then delete all cookies. And the next line we're going to do is to actually have the web page that we're going to connect to open up in full screen mode. And for that to happen, we're going to go and actually use the window property, which is what I was writing before by mistake. And so this will allow us to go full screen. And now we need to pull in a web page. So we're going to get the get command. And what we're going to do is we're actually just going to pull in a web page from Amazon, which I just happen to have here. So I'm just going to go to the Amazon web page. And so I'm just going to copy the URL. Just need to copy https www.amazon.in or .com, wherever you're located. And so you can see that I've pulled in the Amazon web page, and then line 18 actually allows me to go and connect. So here we are, we have the Amazon web page that I'm pulling in. And then what I also want to do is I want to look for a specific ID in one of the elements. And so I have the driver, which is called find an element. And that allows me to look for any element that would be on the actual page. So here we have the HTML in the console screen, and I can actually then paste out an ID from the element that I want to use. So the find element is just the ID for each element, and most of them have them because they need it for JavaScript and CSS. So let's see, there's quite a few IDs, and we can select any of those. So what we have here is we have two-tab search text box, and then what that actually does is that finds the ID for the text box used for searching, and then we're going to use the send key command, which allows us to actually pre-fill in the search box, and we're going to use the test of Puma shoes. This is a fixed string, but you could actually put a variable in here if you want to pull strings from a database or an XML file. And then the next line on line 19 shows how long we're actually going to run the actual script for the search, which is only 10 seconds. And then once the 10 seconds has elapsed, we'll actually quit the script, which actually closes the web browser and takes us back into our screen here. And let's test that, make sure it's working. And everything's looking good. The web browser opens, which is what we expect. It goes to Amazon, fantastic. It now actually goes to the search screen and should fill in the Puma shoes. There we go, Puma shoes. And waits 10 seconds and it closes. And that's exactly what we were expecting. Now you can actually change the unit of time that you would have for the actual test. So if you wanted to see what was happening, so longer than 10 seconds, you can actually change the actual time or the actual metric. So in this instance, we got it as seconds and it's the unit of time, but you could do minutes or hours or microseconds. And you can change the keyword as well. So it could be jigsaws or anything that you wanted to check. But if you're actually building your own application, you want to be able to test your own data against your own application, that's where you put in that specific data. So let's look at the center, the heart of your DevOps environment, and that center is with Jenkins. So before Jenkins, developers would work on their code, and the code would then be checked into a source repository. You would then check for any issues, and then you would then send that code over to the operations team, and there would be a delay for actually delivering software. So the actual challenges developers had is that if they wanted to run any tests, they had to wait until their software was built, and there was a lot of problems in providing feedback, particularly if you had large teams working on software or who actually had the error. The actual delivery of software was often delayed because of these key problems. So after Jenkins, what we actually have is the ability to be able to streamline this whole process. The build, test, and deploy happens continuously and are able to then notify developers and the actual specific developer of any errors that are detected, being able to speed up the delivery process much more efficiently. The focus of Jenkins is that it automates a continuous development, testing, and deployment environment. And it's open source. Jenkins is easy to install and configure. It's been around for many years now, and it is very mature. There are many plugins that you can use within Jenkins to be able to have the Jenkins product work with your environment. If there isn't a plugin, you can actually you can actually write your own plugins if a plugin doesn't exist. So you can actually continue and extend and invest in the Jenkins ecosystem, and it can be easily distributed across multiple machines. So let's break out the architecture of Jenkins. So Jenkins starts as a remote source code repository, and it then pulls out the code every time there is a commit from into the server master. The server master will then have a slave that will run on either Windows, Linux, or Mac OS to be able to distribute its load across those environments. And after it's actually gone through and run its test, it'll then send out a report. The goal of the report is to communicate back to the team what has passed and what has failed, the actual check-in process. Okay, so we're going to go ahead and show you how to install Jenkins on your local PC. So the first thing you want to do is check that you have Java installed. So we're just going to go into our system and see whether or not we have the Java JDK installed. You can do that by going into System Properties, Setting Advanced, and then Environment Settings. And there we are. We have Java JDK installed. And you want to just double check on the system variables to make sure that you have the Java_home installed correctly as well. And we have that installed. And under path, also make sure you have a link to the Java JDK as well. So we have everything installed. And what we're going to do is we're going to open up a command window and just do a double check right there. So open up command window, and we're just going to check that we have Java installed. So we do Java-version, and we have a version number that comes back. If we didn't have Java installed, we wouldn't get a Java version number come back. We'd actually have an error. So everything looks good. So the next thing we want to do is to go to the Jenkins website and download the files. So we're going to go to jenkins.io, and that's the official Jenkins website. And if you want to download, you just go to jenkins.io/download, or you can just type into your search bar download Jenkins, and that will give you a link straight to the download page. And one of the things that you'll see is that there's lots of different versions for Jenkins, because Jenkins runs on pretty much most operating systems, including Windows, Linux, and Mac OS. But we want to select the Windows version. So we've already gone ahead and downloaded a zip file which contains all of the files that we need for Jenkins. And so that's the zip file, and we've expanded it. And what we want to do now is double click the installer file, and we'll go ahead and install that. So we've already installed this. So one of the things that we'll get is a message asking if we want to repair. You would actually get a install message because it'd be a fresh install for you. But once you've done that, it has all the files and all the settings correctly installed onto your Windows computer. And we do all of our commands for Jenkins through a web page that's run locally on your PC. And so you're going to type in localhost:8080, and when you do that, they'll actually take you to Jenkins running locally on your PC. And here we have our Jenkins dashboard. And we've already gone in and created some sample jobs, and you can see those listed on the on the right-hand side of the screen. So let's go through some of the things you would want to set up here. So first of all, let's go into the Manage Jenkins screen, and that will actually, so we'll go to the Manage Jenkins tab on the left-hand side to do some standard configuration settings. So we'll go into the configuration systems, and if you want to, if you're like remotely connecting to a remote Jenkins environment, you can actually install a JDK remotely on that machine if you want to. We already have the JDK environment already set up, so yeah, that's good here. So we don't need to do that. But you'll also see as you go through the list of applications that you have: Gradle, Ant, Maven, Docker, Git, and other tools that you would use in a DevOps environment. There are many other tools you can install through plugins as well. Let's have a look at one more setting here with the security. The default security is Jenkins' own user database. That probably is not allowed within your company due to security restrictions. So you can choose LDAP, which allows you to connect with your Active Directory configuration. Again, because there are so many plugins for Jenkins, there are plugins for SAML authentication as well as OAuth. So let's go ahead and start a new build job. And so we'll select a new item, and we're going to select demo 1 from that to create a new item. And we're going to use just a freestyle project because I just want to demo how you can actually create a build. Select OK. Description, gosh, what can we write here? We can put in Snippy demo. And we're not going to use source code for this one. We're going to do that in the next demo. But what we want to go down to is the job type. And we're going to, build, we can just do add for execute Windows batch command. And so let's just put in a very simple command. And so we're going to type in echo, open quotes, hello world. And then we'll put in the timestamp. So we'll put in date first and then time as part of our output. Close quotes. And we're going to save that. Also hit save. And that's our simple project. So what we want to do now is we want to actually go and select the build now command to actually run this project. Hit build now, and it'll take a couple of minutes for it to run. And here we are. This is our project, and we can actually now see the different builds that have happened. And if you look on the build history, you'll see the latest history shows when the build was executed. And if you click on that, you can actually start getting information such as the console output will actually provide information that we were asking for. So for instance, we have, first of all, we can see that the build was successful, and we see the output includes the hello all and date and time. So we're going to go ahead and create one more project where we can actually connect to a GitHub and use the Git command tool to be able to build a real project. So we're going to go ahead and create a new item, and we're going to call this one Jenkins. It's a freestyle project, and our description is demo using Git. So we're actually going to connect to GitHub. So to do that, we're going to go into Source Code Management tab, and we're going to select Git. And so we select that. We can actually now connect to GitHub. So to do that, you go to your GitHub account, and you want to go in and select the clone or download, and you get the URL link from there. So copy that, go back to Jenkins, and add that in the repository URL. So you paste that in. And then for credentials, we want to add in our Jenkins credentials. And so just make sure you have those selected correctly. And we've select add. And then we just pull those from the drop down. And let's not change any of the other settings. And then for the build, we're actually going to be building a Java application. So it's a slightly different set of build commands. So we want to type in javac for compile, and then space, and the file name is simply.java, and then you want to put java and space simply on a new line. Save that. Again, this is a really simple application, but it gives you the understanding of what you need to do here. And so we saved it, and let's now go ahead and see if everything's working. We'll do the build now and see what happens. And here is our first build. We select that. We can go to the console output for details, and what we can actually see if we scroll down is that the finished output at the very end says success, which means everything was built correctly. And so that's how you're able to connect Jenkins with a Git repository. And the thing that's great with working with Jenkins is that it connects to so many different systems and really does become the central point of your DevOps toolset. So let's start looking at the operations side of the DevOps environment, and let's focus in on Docker. So before Docker, the problem you had as a developer, if you're working on a virtual machine, the actual virtual machine was your VM, was a very complex piece of software. So first of all, VMs have not been around for very long. We're talking about less than 10 years. And the typical way of having a VM is that it's very heavy on usage on your computer. You essentially are running everything of the VM plus the tools to run the VM on your computer. With Docker, what you're able to control is the actual development environment you're working in. You don't have to be encumbered by all of the additional extraneous processing that a VM environment has. You're really stripped down to just the bare minimum that you need to have to run the environment using a containerized solution known as Docker. So Docker is essentially an OS level virtualization software. It is a maturity of the solutions that were started with virtual environments, and there are other solutions out there. Docker has become the de facto container solution that you can use for building out and guaranteeing that what the developer is building is going to be the same as what the operations team will use. So Docker itself is highly scalable and efficient. You can have many Docker environments running on a single piece of hardware. The boot up time is incredibly short. You can reuse the data volumes very, very easily. It's not complicated. And the actual applications are completely isolated. This is like a perfect sandbox environment. So let's dig through the architecture of Docker. So there are really two parts to Docker. There's the Docker engine and there's the Docker client. The Docker engine is comprised of the Docker CLI, which connects with the server daemon. The Docker client will then issue the commands to the Docker daemon. And then the Docker daemon will then interact with your system to be able to provide the tasks and tools needed for you to be able to build out your solution. The actual images that Docker uses are instructions for creating Docker containers. And the actual Docker container itself is a lightweight package that contains all the dependencies needed to run an application. Now, once you have created a container that is of value to your team, you want to be able to store that container so that other team members can use it. And this is where you would use a Docker registry to be able to host and distribute multiple Docker images. So in this video, we're going to go ahead and see how we can get Docker installed and running. So we're going to go ahead and open up our terminal window, and we want to validate whether or not Docker is installed. If you haven't installed Docker, you can actually go ahead and use the following command, and that is to enter in sudo apt install Docker, and that will go ahead and run the command to install Docker. I already have Docker installed on my system, so I'm not going to do that right now, so I'm just going to delete that out. But what I am going to do is check to see what Docker images I have installed on my system. And to do that, I'm going to type in sudo docker images. And when I run this will actually show how many images I have. And as right now, I don't have any images at all. So why don't we go ahead and install an image? There are two ways you can create an image for your Docker environment. One is to get one from Docker Hub, and the other is to create your own image. Let's go ahead and get one from Docker Hub. And so the command line that we'd want to write is sudo docker pull redis colon, and after the colon, we're going to actually write the name of the actual file that we're going to be connecting to from Docker. So I'm going to go ahead and go to Docker Hub, and I've already logged in with my user ID and account. So I'm going to go to Docker Hub, and it's hub.docker.com is the website address, and I'm already logged in with my Simplilearn account. And what you can actually see is different repositories that I have already created below. But I'm going to click the Explore button, and I can see the Redis image, and these are all the different commands that I can actually use, all the different variations that I can create. So I can do 5.0, I can do a 32-bit version, I can do a 4.0 version or a 3.8 version, or if I select latest, that will allow me to just pull the latest version even if it's updated. So I'm going to go back to my command line and do latest, and what's going to happen now is that we're actually going to pull the files live over the internet and create the Docker image. So this is going to take just a few minutes. Of course, if your internet speed is faster, then this will happen a lot faster. And here we are. We have everything downloaded, which is great. And so let's just go and check and see if the image has been added to Docker. So we do sudo docker images, and now you can actually see that we have the latest Redis image, and it's given the default image ID, and there's the size of the Docker image. And the tag is latest, so it's the latest version of Redis. And I'm just checking to see if there's any other images running, and no, there isn't. So let's go ahead and now create a container. And so the command for that is sudo docker run -d -p 0.0.0. I think it's .80:80 space redis :latest. And let's run that. Got an error message. Okay, now you know that it's a real demo. This is really live. So I'm just going to clear the screen and let's write that in again. So sudo docker run -d -p, and it's 0.0.0.0:8080 redis.latest, and there we are. Everything's up and running. Awesome. So let's just go ahead and check that we actually have the image running in Docker. So sudo docker ps, and there you can see that we actually have the latest Redis version, and it was created 16 seconds ago. We have a new container ID for it, and there's our port that we've created. And let's see if we can view all the running containers. And sudo docker ps-a, and there we are. And we created that container 42 seconds ago. But one of the things you'll notice is the name for the Docker is created automatically by Docker. And here we have Stupefied Engelbarts is the name. Let's change that name to something that's more meaningful for the work that we're doing. So that's actually fairly easy to do, and it's going to be our final task here. So we're going to type sudo docker, and the command is rename, and we want to copy over the old name, and then we put in the old name, and then you do a space, and then you put in what you want the new name to be, in which case we're going to make it Simplilearn. We run that command. That's good. Now let's validate that everything has been changed. So we're going to do sudo docker ps-a, just ps. And there we are. Everything has been renamed. And that gets you started working with Docker. Now let's move on to Ansible. So before Ansible, the ability to be able to deploy software across a network was pretty hard. You couldn't guarantee that your web servers were all consistent and that the database environments were consistent. This was okay if you had a small environment, but once you actually start getting into more complex environments, it became very difficult to manage. Ansible is code that allows you to be able to consistently and reliably create and stand up the environments that you need to be able to store your code for production. So whether or not you require one server environment or you need 1,000 server environments, using tools like Ansible will allow you to be able to consistently deploy out environments that all look the same. So essentially, Ansible is a configuration management tool, and it allows you to be able to deploy automatically to a large variety of environments. The actual tool itself is a push-based configuration tool. It is an agentless tool, so there is no communication coming back about the health of the environment. We actually have tools that we'll cover later on in the video that cover that. Ansible does have a consistency of its product performance, so you know that if you're using Ansible that it's going to work. It's just a very consistent product, and it uses SSH for very secure connections. So it doesn't matter whether or not you have 1 or 1,000 pieces of hardware you're looking to configure, you can actually be rest assured that there will be no security infringement because of the use of SSH. And we look into the architecture of Ansible. It's a very simple architecture. There is the Ansible management node that has playbooks which contain the instructions that you would have for your environment, and that playbook is then pushed out to all the different nodes that contain the hardware that you wish to configure. The actual module collection is the configuration code itself. The playbooks are the instructions of that configuration. And then the inventory is the document of the different groups and the hardware within those groups that you would be pushing out to. So we're going to go ahead and install Ansible onto the system here. And we're actually running our environment in a Linux environment right now. So we have a master environment and a standard node. But we're actually going to go into our terminal window and we're going to do everything on the master node. So the first steps we want to do is actually go ahead and install Ansible, and we're going to do that by installing sudo yum install ansible -y. And this goes ahead and downloads all the files that we need and starts to run the installation. And let's go ahead and see if it's installed correctly. So we're going to type in vi-etc/ansible/hosts. And there we see we actually have a default Ansible hosts already up and running, which is fantastic. And we want to grab this IP address, which is Ansible servers, and then the IP address with the password and root access. And the IP will be specific to your local client. So this is my client system. So if I type in my config, I'll actually see that the IP address matches up, and then you want to make sure that the IP address is correct for your environment. And so this is essentially a node in the Ansible environment, and this is the IP address and the password for that node so we can access correctly. So we're going to hit colon at the bottom of the screen and take ourselves actually into Ansible. And what we're going to do now is create a playbook to be able to run a sample script. So we're going to call it vi-sample.yml. And here we have a sample playbook. We have the name, we have the host, we have the root user, and we have the task. And in the task, you actually see that we're looking to create a virtual web page with the content of welcome, so that we can actually see that the web page is loading. And all of this is written with a very basic XML format called YML, which stands for yet another markup language. But it's very flexible and it's very easy to learn. So let's see if we can go ahead and actually run this playbook so you can actually see it in action. And so we're going to type in Ansible-playbook sample.yml, and this will run the sample YML script --syntax-check. Then we type in Ansible-playbook sample.yml. So I had some issues there, so I'm going to try that again. And let's go in and write the command again. So Ansible-playbook sample.yml-syntax-check, and then run the actual playbook itself. And let's see if it works. Yes, everything's working. And it'll take a moment for everything to initialize. And now what we want to be able to do is go back to our web browser and see whether or not we were able to create that default web page with the word welcome in it. Because that was the command that we created in our playbook. And there we are. There's the word welcome, exactly as we planned. And we can go back and we can review the playbook that we created just to validate that. So let's go back into screen here, and let's go in and look at the YAML page. And there we are. We see that the word welcome is there, exactly as we expected. Now let's step into our final area, which is network monitoring using a tool called Nagios. So before you had Nagios, sometimes you didn't know whether or not your network was working. In fact, the worst case scenario was when your customers called up and said, hey, your website's not working. The challenges you had is that you didn't know how the usage of the server was being managed. You didn't know whether you were up to 80% usage, utilization on that server, or if you were at 50%. It was difficult to get that information easily. With Nagios, you're able to set up email notifications and other notifications that allow you to stay ahead of issues that you would have within your environment. So with this example, if you're looking for memory utilization, you can receive a notification telling you that your memory is almost full on a particular server and that you should be setting up a new server. In this instance, use Ansible to set up another server. So again, as with the other tools that we've been covering, Nagios is an open source tool, and it's specifically for monitoring systems, servers, and networks within your infrastructure. Very easy to use. It has comprehensive monitoring tools that you can set and control. It is highly available, and it is designed specifically at problem remediation. You want to set it up so that it is the eyes and ears of your network without you having to constantly monitor your network. So the way that Nagios works is that it's just constantly checking out your environment. So the Nagios server is constantly checking the status of your systems, and then is able to create visualization tools of that data. So you can actually then make quick responses. Or you can even send out alerts, such as an email alert or a push notification alert. In this video, we're going to take you through the steps that you need to follow if you want to set up Nagios and the dashboard Nagios provides to help monitor your network. So the first thing you want to do is go to nagios.com, and you can either download the application, or you can actually do what we're going to do here is actually just log into the actual application running on the Nagios website. So for that, you want to go to nagios.na.demos.nagios.com, and you can use the administration or normal user access IDs that Nagios provides. And we've gone ahead and we've actually pre-filled in our ID with Nagios admin and Nagios admin for the user ID and password. Of course, you wouldn't do that in normal real life. So that brings us into the Nagios dashboard. And what you're going to notice is that there are three distinct areas that you should want to focus on. You have the fixed sources, which is all your actual physical hardware that you're monitoring. You have alert summary and abnormal behavior. So let's go check out the fixed sources. And so we have two default fixed sources here, and one in Chicago, one in Tulsa. And you can go ahead and set up additional sources, but what you'll see is that this provides a quick dashboard of the activity in the last 30 minutes, the amount of usage on the disk. You can go ahead and under the behavior tab, and you can modify how you're monitoring and updating the actual source itself. And then the data from these reports will be from these sources will actually be then used in reports, queries, and alerts that you'll use. So we're going to go back to the board, and here you are. Here's the two fixed sources. So let's look at alert summary. We're going to expand that out. And the alert summary provides just an overview of the alerts that are being managed. The alerts that you see here are the default alerts that have been created as part of the test environment. It's very easy to create alerts, and in this instance you can see that the Chicago source is being used to manage the alert. What you can do is when you're actually setting up your own sources, you'll see that the alert will then point specifically to the source that it's pulling the data from. So in the PowerPoint, in the presentation that we just went through, you actually see how Nagios actually is the center of collecting all the information, but it's actually pulling the information from the different networks and environments that you have, and then it stores that data locally to be able to create the visualizations and the alerts. And we have here just a quick overview of an alert here inside of the summary, which actually shows green, which shows that the alert is actually good. Now, there are three different types of colors. There's green, yellow, and red, but as you can see, we have no critical alerts right now. And you'll see the same thing happening at abnormal behavior as well, where it actually goes ahead and shows you the different colors that are available. The thing that's great is that as soon as a warning status is created, then it allows you to trigger an email notification that gets sent out to you and has information in the email which you can then action. So the alerts are very important, and the alerts again are pulling the information from the fixed sources. So the abnormal behavior is just going to zero in and show any specific abnormal behavior that would be happening with your fixed sources. And so in this instance, it's around bandwidth, and everything is green, so everything's looking good. So we're going to the source tab, and we're going to look at the bandwidth graph, and this is a more detailed visualization of the bandwidth that's happening through the Chicago fixed source. Again, you can create your own fixed sources, and you'll be able to see the actual usage, such as the bandwidth graph for that fixed source on this screen. And at the bottom of the screen, we have just kind of the most popular information that most network engineers are looking to assess on how a network is being used. So we can go ahead and we can select reports, and we can actually come in and we can either create our own custom report, or you can use one of the many saved reports that are already there. If you're new to Nagios, use the saved reports, because you'll be able to get in and get the great visualization tools that Nagios provides very quickly, and be able to then action the information visually from what you're looking at. These reports are absolutely fantastic, and they're also really good to send to other team members that would have an interest in understanding the network usage and the different areas that you're managing. Now, if you want to get really specific on the type of data that you want in the report, you can actually go in and create a query, and the query can be customized to really however you want it to work. The points of view very specific insights into different data points that interact. They're very easy to create. A lot of them have been created, as you can see on the screen already. And as you can see on the left-hand side, there's an edit button that allows you to edit and modify those points of view very quickly. Now we're going to go ahead and create one right now, and we're just going to put one in. We're going to put the limiter for an IP address. We're going to change the data lifetime. We can either do hours, days, or weeks. We do 24 hours, that's fine. So we'll just go ahead and we'll see what we have on the screen. And as you can see, there are just a lot already created. Select one, we'll edit the FTP, and we'll see what the data lifetime for that is, and it all looks good. So a query will show all of the saved queries you've created, but you can actually go in and modify a query very easy. You can go in and create a query and really essentially ask it to pull any kind of information that you would be looking at analyzing that has been captured by Nagios. And there's a dictionary you can use that Nagios has on their website that allows you to get better access and understanding the querying constructs you can put together. The alerts, in my opinion, are the most important part, because these are the actual actions that interact with the data sources and will trigger alerts that get sent to you. So if we go back to the presentation again, you can see that we're analyzing a lot of data, but it's the data that gets sent to you as an alert that allows you to immediately understand why you need to be able to go in and check out your network. And this is why you're really using Nagios, because you need to have those alerts. And so what we're going to do here is we're going through the steps you'd use to create an alert, and we're just going to do an alert here that is going to be on analyzing bytes of traffic. And the final step is to actually go ahead and save the alert and really put in what the alert notification model method is going to be. The default is to use an email, which is great, but you can use a Nagios alert or SMP, a simple network protocol alert, or just use a command. Email is definitely the easiest one to use, and so getting started, I would recommend you use email. So we're going to go ahead and we're going to create one. We're going to do one on workflow, and we're going to set up the way in which we're going to manage this. So the threshold is going to be 34 bytes with a critical threshold of 50 bytes, which is very small. I expect an alert to be triggered because of this. And we're just going to use the default emails to send out. And you'll see by default that the new alert is now impending. And the reason why we have it impending is that it's just there to be reviewed by the system to make sure it meets all the standards. I don't think that'd be a problem. And I'm just looking at some of the other different commands we have here. So if we go back, and we can get alerts from other Nagios networks. We connect to different networks right from this configuration screen. Same thing with the SMP receiver. We can use simple network management protocol to connect to other receivers. And the command tab allows us to create scripts that can be triggered from alerts that get created. So you may want to have something that triggers a rebuild of a network environment, which would allow you to authenticate through other systems. Now, of course, there are other things that you can set up in the Nagios dashboard. So, things like information on your profile, defaults here, such as language and your username. You have the same thing for a system administrator, where you can actually go in and set defaults for the sysadmin. There's LDAP AD integration for simple for SAML authentication. Go back to the main dashboard. If we scroll down, you'll actually see that we have an alert has been approved. That's the alert that we created before, and it's now saying critical because more than 50 bytes of information have been sent over our test network in the fixed source of Chicago. Surprise, surprise, 50 bytes is very easy to do. So it's good to see that the system is working correctly. And this is how our Nagios environment works. And from here, the next step is for you to be able to set up and configure Nagios to run with your infrastructure.
Thanks, Matthew. Now we have Anjali, Apeksha, Matthew, Anaga, and Anant to take us through the major concepts of Git, Selenium, Jenkins, Docker, Chef, and Puppet.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.